Welcome to homework.
So we have to find the concentration of hydroxide in a solution of sodium hypochlorite with 6.5 percentage a mass percentage. So it's weight by weight. And then we also have to find the pH of the solution. So first of all, we have to find out the amount of sodium hypochlorite in the solution. So assume we will have say 100 milliliter of our solution. So, and we are given the mass of our the density of our solution is equal to 1 gram per milliliter. So therefore, we have 100 grams of our solution. So because with that 100 gram of our solution, we should have 6.5% of sodium hypochlorite. So in other words, we have 6.5 grams of sodium hypochlorite. Okay, so in other words, we have to convert that concentration from percentage to mass, and then we can convert that to molarity. So first of all, we have to convert that mass to molarity. So the number of moles of our sodium hypochlorite will be equal to 6.5 divided by our molar mass will be 74.4 gram per mole. And then we should have 6.5 divided by 74.4, 0.087 mole. All right, so we have the number of moles and the concentration of our sodium hypochlorite will be equals to, because we first assume that we have 100 ml, so the volume will be 100 ml or 0.1 liter. So we are going to have our number of moles divided by 0.1 liter. And then we should be able to find that we have 0.87 molar of our solution. Okay, so we have the concentration. We can proceed to find out the concentration of hydroxide and then the pH. So first of all, we are going to separate these two ions. We have sodium plus and also hypochlorite ion. For sodium ion, it's a spectator ion, so it doesn't do anything. But for hypochlorite ion, you're going to react with water to produce a hydroxide ion, and also with our hypochlorite acid. And then we can set up our ice table for this reaction. So we have 0.87, and then we have 0.87 minus x, and then we have 0, 0 plus x, x. And because we have a beta ionization reaction, so we're looking at Kb. So Kb equals to x squared divided by 0.87 minus x. Okay, so the next step is we want to find out the concentration of hydroxide ion. So we're going to, we need Kb. So how can we find out Kb? And if you look for the pKb of the hypochlorite ions, the pKb actually is given to be 6.4H. You can look it up online or from other source or even from a textbook. So in other words, we will have 10 to the minus 6.48 Kb for our for Kb. Okay, so if we also want to convert Kb back to another number, we should be able to find that it's around 3.31 times 10 to the 7. Or actually, if we look at this number here, over here, Kb will be less than 10 to the minus 5. So in other words, the dissociation or the ionization will be very small. So X will be very small. So when X is very small, when compared to our initial concentration, it will be also very small as well. So it will be insignificant. So the initial concentration, subtract X, will be approximately around the initial concentration. So we will have, we just need to remove X over here. So we have X squared divided by 0.83 times equals to Kb. So if we solve for X, we have 0.87 multiplied by Kb. And then we should have 0.87 times 10 to the power 11 is 6.48, and then square root of the answers. And then we should be able to find that X equals to 5.4 times 10 to the left 4 molar. And this will be the concentration of our hydroxide ion. Okay, so next step, we have found the pH. All right, so let's copy and paste our concentration of hydroxide ion equals to 5.4 times 10 to the -4 molar. Okay, so for this, for here, we can find pOH. We are going to take a left log of our numbers, and then we should be able to find it as equal to 3.3. And pH will be equals to 14 minus 3.3. And then we should be able to find that the pH equals to 10.7.